Hello. So I thought I'd work on this example. We are asked to find the equation of the tangents to the curve with the implicit equation. Because here's our implicit equation at the point 2, 1. And so I just denoted that as p. So to point p 2, 1. So we need to find the equation of the tangents. And so what we want to do, we have to use implicit differentiation here. So we're going to differentiate this equation with respect to x. So I'll just write that diff with respect to x, right? And and one might want to even graph this equation. I'm sure the curve looks quite cool, but in any case, I'm not going to worry too much about that in this video. And to be honest, a lot of this is probably quite simple. I mean, to find the equation of the tangent, if one's working in implicit differentiation, they should already know how to do that. But and so perhaps the trick is just more about thinking about the implicit differentiation itself. But in any case, let's just work through it. And so we need to differentiate this equation with respect to x, as I've said. We've got our, well, what's that going to come out? Well, let's just start here. We've got 2x, right? Differentiate that as 2x. We need to use the product rule here for this 3x y squared term, so I'm going to drop in some brackets. Let's differentiate y first. We've got our 3x times, what is this? This is going to be 2y times dy by dx. Close the brackets there. And we're not quite done, right, with our product rule. We now need to differentiate this, focus on this x term. So we can write y squared times, and this just differentiates to 3. Our x term differentiates to 3. And now we can close the brackets. We've got this negative y cubed term. When we differentiate that, we get 3y squared, negative 3y squared by dy times by dy by dx. And of course this constant 9 is just not, right? We get 0. So that's our implicit differentiation finished. We could tidy this up, couldn't we? I mean, this is just 3y squared. We could, but let's just leave it. I don't have to write it all out again, because all we need to do now is insert our values for x and y, right? Because we need to find the gradient of the tangents. So what we're going to do is just, I'll write it this way. How about make it kind of explicit? When x equals 2, y equals 1, what do we get? Well, let's just insert our values. We get 2 times 2 plus, I will write it out. We could probably do this in our heads, but I'll write it all out for the sake of the video. Get 3 times 2, and then again that's multiplied by 2 times 1 by, and remember we've still got our dy by dx here, that doesn't go away. So close the brackets there, plus we still got this y squared term, so that's 1 squared, and that's being multiplied by 3. Close the brackets completely. And now we're just left with this negative 3y squared term. And that's just going to be 3 times 1 squared. And again, we've got our dy, that being multiplied by dy by dx. And all of it set to equal 0. So this should simplify quite nicely. Perhaps one's already done it in their heads. It's just 4, that's 6 times 2, that's 12. And then we still got our dy by dx. So times dy by dx. Plus, this is just, or is that negative? No, that's right. So that's just plus 3. Yeah, that's right. And now we've got this term here. That's just negative 3 dy by dx. So it simplifies quite nicely for us. But we're not done yet. We need to make dy by dx the subject. So let's subtract 4 and 3 from both sides, and let's then factor out our dy by dx. So what does that leave us? That leaves us with, and maybe I'll write it like this. It implies that dy by dx multiplied, well, it's going to be 12 minus 3, right? Because I've just factored that out. It's common technique. implicit differentiation. And then we've got a -7 here on the right hand side. And so that, let's just say that implies again, if we make dy by dx the subject, well, 12 minus 3 is 9, so we're going to end up with -7 over 9. My computer's a bit laggy, but hopefully it doesn't affect the video too much. So there we go, that's our gradient. I'll just box it off to highlight it. And I could write it out, therefore, maybe I'll just do that for the sake of it. Therefore, the gradient, just to make it clear, the gradient at the point at the gradient is -7 over 9 at, and our point was 2, 1. However, we are asked to write the gradient of the tangent. Now that's, or the equation of the tangent, sorry. So this is our gradient, this is the gradient of the tangent here at the point 2, 1, right? But the question asks us to write or find the equation of the tangent, so let's just do that and we will be finished. So, well, we know, one should know this, that y minus y sub 1 equals m, which is our gradient, times x minus x sub 1. And we have all the values here, right? We can just write y minus 1, right? Because at that point, y is 1, equals our gradient, which is -7 over 9, times x minus 2. And we can simplify all of this, of course. It's just y minus 1 equals minus -7 over 9 x minus, plus double negative 14 over 9. And it just so happens that we have a common denominator here, so let's just multiply 9 by both sides. And just to save space, I'll write it over here. It implies we multiply by 9, both sides of this by 9. To cancel the denominators, we get 9y minus 9 equals 14 minus 7x. And we are almost done. We just need to rearrange this a little bit. So we want the x term on the left, and we want our c term on the right, so therefore we get 9y plus 7x equals 9, 14, that's 23. And that is the equation of the tangent at the points 2, 1. Now this last part is should be very simple, right? And one likely be very familiar and perhaps even grown bored of having to find the equation of the tangent. So I suppose the real focus is just the points at the earlier parts of just differentiating this implicit equation. And it's just very simple. We're just using the product rule here. We didn't have to use a chain rule or anything like that. And we got and then we just substituted in our values at the point P to get the gradient of our tangent, and from there is quite simple. But in any case, that's the final answer. That is the equation of the tangent.